Okay, let's continue our discussion. So in this video, we are going to discuss Young's modulus and we will take one example related to it. So here we have rod. This is the rod and this rod is clamped at one end and an external force is being applied on the other end. Here this external force is trying to stress this rod. So there will be tensile stress in this rod. There will be a restoring force which will oppose this external force. Let's write it FRES. And if this cross-sectional area is A, this tensile stress will be F restoring, or if this thing is not under acceleration, so this restoring force and external force will be the same. So let's write F only per unit area. And then there will be change in its length. Let's write delta L is the change in its length and L is its original length. So this ratio will be strain. Now, as we know, this sigma is proportional to stress is proportional to strain within certain limit, and then we can write sigma equals to something constant times, and this proportionality constant is known as this proportionality constant is known as Young's modulus. So we can write Young's modulus equals to sigma by epsilon, or we can write F by A divided by delta L by L. So from here we can say what is its SI unit, and you can easily find out. This will be unitless, and this is force per unit area. So its SI unit should be Newton per square meter. Now here we have a table showing Young's modulus for some substances here: aluminium, copper, iron, wrought iron, and steel, glass, concrete, and so on. So here what we are observing, this ultimate tensile strength. We have discussed ultimate tensile strength and yield strength, all these things. So what we are observing here, this strength is very high here in these cases. So we can say, and of course here we have Young's modulus also. So we can say these materials have high tensile strength. And if we have to choose which one out of these four, let's say, which one should be used in making heavy machinery based on tensile strength or large constructions, so we can say this steel should be our reference here. A structural steel rod has a radius of 10 millimeter, so R equals to 10 millimeter, or we can write it 10 into 10 to the power minus 3 meter, or simply 10 to the power minus 2 meter. Okay, next, length of this rod is, let's say, L, 1.0 meter. Okay, and then a force of 10 kilonewton. So force is 100 kilonewton, sorry, 100 kilonewton, or we can say 100 into 3 newton, 10 to the power 3 newton, so 10 to the power 5 newton. You can check it by yourself. 100 into 10 to the power 3 newton should be this one. So what we have to calculate, number one, stress. So stress will be here, this tensile stress should be force per unit area, and force is given 10 to the power 5 Newton divided by area is, this is radius, this is rod, so its cross-sectional area should be of circular face. So this should be pi r square, and we can write here pi, and r is this much. So square of this thing 10 to the power minus 4 meter square, and then we can calculate this part, and you should do it by yourself. It should be somewhere 3.18. I am taking directly answer from your textbook. 10 to the power 8 Newton per square meter. So this is one. Now, what about elongation? And Young's modulus is given here. So elongation should be delta L here. Delta L by L is strain times Young's modulus should be stress, that will be force per unit area, which we have just obtained here. So delta L should be L by Y into force by area. So L is 1 meter. We can write here 1 meter, and Y is given here 2.0 into 10 to the power 11 Newton per square meter, and then force per unit area, which is stress here. So this will be 3.18 into 10 to the power 8 Newton per square meter. So here we will have here we will have delta L, and we can calculate this part. So delta L should be 1.59 into 10 to the power minus 3 meter. So this is change in length. Now what about strain? So strain should be delta L by L. This is strain. We can write delta L is nothing but 1.59 into 10 to the power minus 3 meter, and then length is 1.0 meter. So here we will have strain as 1.59 into 10 to the power minus 3 units. And if you want to know what is percentage, this is strain, longitudinal strain. So percentage should be delta L by L into 100. This is fractional change, so this will be multiplied with 100 to give us percent change in or percent strain. So this will be 1.59 into 10 to the power minus 3 into 100. So this will be 1.59 into 10 to the power minus 1, or 0.159 or 0.16. So this much percentage is there in strain.